Well, now the first thing we need to do is proving the law of reflection from Huygens principle. Okay? Why? Because law of reflection is something we have learned in ray optics, where we considered it to be traveling in a straight line. But now we are saying that light travels in a waves, and if it travels in waves, it should also prove this basic rules. If it is not proving these basic rules, we can't consider them to be correct. Okay? Now, say we have a reflecting surface. Okay, say this is a smooth reflecting surface, and there is a parallel beam of light incident on this surface. Okay? After reflection, what will happen? Okay, so they will reflect in such a way that angle of incidence should be angle of equal to angle of reflection. That is what we need to prove. Okay. Okay. I just need to change a little. Make a little change. Okay. The diagram won't be much different, but I need a broader angle. So. Yes, into wider. Yeah. Now, see, this is the point of incidence. So, at the point of incidence, we are trying to figure out the incident wavefront. Now, what is the directional sense relation between wavefront and wave?
Perpendicular.
They are perpendicular to each other, right? So, if I draw perpendicular to this parallel beam of light, then we get this as the incident wavefront. Okay? And after the reflection at this point, if we draw a perpendicular to both of them, then that is the reflected wavefront. Yes or no? Now, at the point of incidence, if we draw the normal, let's see normal term क्या होगा? This is the normal over here. This is the angle of incidence, I. Okay, and this is the wavefront. Let's mark them up. Let's mark them up according to the diagram. Say this is AP is the incident wavefront, and A dash P dash is the reflected wavefront. Means the rays that are coming over here at the points A and P, the ray reflected from A comes to A dash, and the ray coming from P is incident at P dash, and after that it is getting reflected. Is that clear? AP is called the incident wavefront, and A dash P dash is the reflected wavefront. You know this angle is how much?
90.
Of course, this angle is also 90 degree, right? अब एक चीज मुझे बताओ, ये एंगल I है, तो obviously this angle is 90 डिग्री माइनस I. अगेन ये जो लाइन है, सॉरी ये नॉर्मल है ना, तो अगर ये 90 डिग्री माइनस I है, तो ये वाला एंगल क्या होगा? This whole angle will be I. So this is I. This whole angle will be I. Similarly, this is the angle of reflection R, normal के respect में. So this angle is 90 degree minus R. So this whole angle will be R. Alright. So we need to prove that I is equal to R. That can be actually done in two ways. আমি যে মেথডটা করাচ্ছি, this is the one that has been followed in NCERT. NCERT में जो follow किया हुआ है, I'll be doing that method. ठीक है? There is another way you can do it by proving congruency of triangles. Take these two triangles and try to prove the congruency of these two triangles. You can say when once you prove these two triangles as congruent, you can say these are corresponding angles of congruent triangles, and then say that they are equal. But I'll be using the NCERT method. Now, what is the NCERT method saying? It says that let us consider another wave which is traveling in between. Okay? And after incidence, it is getting reflected along the same direction. So this point on the incident wave, say this is Q. This point is Q, and it is incident at the point A, and is reflected back to the point Q dash. This point is Q dash. Look at this very carefully. This point is Q, this point is Q dash, and it is incident at the point K. Okay? Is that clear? Huh? Up. Now, if we want to find out the time taken by light to reach from the incident point Q to the Q dash, incident wavefront to the reflected wavefront. So, AP is the incident wavefront, A dash P dash is the reflected wavefront, Q is any point on the incident wavefront. Q is any point on the incident wavefront. Ray through Q is incident at K and reflected along KQ dash, where Q dash is a point on the reflected wavefront. On the reflected wavefront. ठीक है? अब एक छोटा सा क्वेश्चन है. I'll give you time to write. पहले एक बार जल्दी से समझ लेते हैं ये वाला चीज, and then I'll give you time to write. Now listen. Therefore, time taken by the wave to travel from Q to Q dash is t equal to. If you know the speed of light, then how do you find out time? Distance by speed, right? So distance क्या travel कर रहा है वो QK plus K Q dash वैसे. So it is QK plus KQ dash by, yes or no? Where C is what?
Speed of light.
Speed of light. Now we are making small analysis in triangle AQK. Can you say AQK? AQK. Can you see this? Tell me how much is sin I? Sin I is, this is I, this angle is right angle, okay? Sin is perpendicular by hypotenuse, right? So it is QK by AK. You agree with this? So can I write QK as AK sin I? Correct? And in triangle क्या है? KQ dash P dash. KQ dash P dash. Can you see this small triangle out here? KQ dash P dash देखो बच्चों. In KQ dash P dash, what will be the value of sin R?
KQ dash by KP
So it
dash.
is KQ dash by
KP dash.
KP dash. Right? So KQ dash can be written as KP dash
Sin R.
sin R. Right? We can do that. Now I'm making the substitution over here. I'm writing that this QK is what?
AK sin I.
QK is AK
AK sin I.
sin I by C plus KQ dash is KP dash
Sin R.
sin R by C. Right?
सर
Now,
आप Q dash नहीं लिखा.
oh, KP dash.
उधर.
Oh, Q dash is side. KP dash. ये same था, ये same. अच्छा, अब now let it be AK sin I by C plus KP dash can be written as AP dash. AP dash minus
AK.
sin r by c, right? Now if we just simplify this, break this up, it will be ap dash sin r minus ak sin r, and then if I take the ak common from both of them, this will become ap dash sin r by c plus ak sin I minus sin r by c. Yes or no?
Yes, sir.
हाँ, एक बार बोर्ड में देखेंगे सब लोग, प्लीज डोंट राइट। एक बार एक इंपॉर्टेंट चीज है यहाँ पर, हाँ, थोड़ा ध्यान से सुनो। यहाँ तक सब लोगों को समझ में आया? अब टेल मी AP डैश sin r है क्या? ये AP डैश है, हाँ या ना? और ये r है, तो AP डैश sin r करने से क्या आता है? देखो sin r in which triangle? A dash B dash. A dash B dash दिख रहा है ट्रायंगल, A dash B dash, उसमें sin r क्या होगा बताओ?
A dash by AP dash.
Right.
AP dash.
A dash
By AP dash.
by AP dash. You all agree with this? So can I write AP dash sin r is equal to A dash? Yes or no?
Yes.
तो ध्यान से देखो, तब can I say this AP dash sin r by c is equal to the total time taken? क्योंकि q को q dash में आने के लिए जितना टाइम लगेगा, a से a dash में आने के लिए भी why? Because all the points on the same wave front has started the vibration at the same instant of time, because they are the locus of all the points vibrating at the same phase. So यहाँ पर जितना भी points है, सारा points यहाँ पर आएंगे at the same instant of time. So can I say कि q k और k q dash में जाने के लिए जितना टाइम लगा, a से a dash के लिए भी उतना ही टाइम लगेगा. So this whole thing is nothing but t. तो फिर इसका क्या फायदा है? कितना होना चाहिए? 0, right? यही अगर पूरा टाइम ले लेता है, this is taking up the whole time, then this should be 0. So if I write this is equal to 0, then sin I minus sin r is equal to
0.
So that is sin I is equal to sin r, that is I is equal to sin of incidence is equal to angle of reflection. Yes. So now what we need to understand, what we need to write after this, what we need to do is we need to show this one. Another report. Now total time t is equal to a dash by c. Also total time t is equal to a dash by c, which is ap dash sin r by c. Therefore ak sin I minus sin r by c is equal to 0, right? So if this is equal to 0, that implies sin I equal to sin r, and that implies I is equal to r. Hence the law of reflection. जल्दी से बना लो.